In a world experiencing both rapid population rise and an ever-increasing dependence on technology, securing safe and reliable power sources is one of this century's great challenges. The past dreams of cheap, everlasting energy from fossil and nuclear fuels are quickly evolving into nightmares, with devastating effects becoming ever clearer amid the voices proclaiming the something-for-nothing myth. But the world does offer us plenty and for very little. We just don't seem to be good at taking advantage of it. We have wind and solar power, which, although not always dependable, can be harvested and stored. We also have the oceans, which are a constant source of untapped power. The height of tidal ranges vary throughout the world, but can be quite spectacular at over 16 meters. These huge bodies of water are raised and lowered for free not once, but twice every day and at specific and predictable times. So why don't we capture that dependable energy? The answer is simple. We have become addicted to short-term, easy choices and have denied reality. There is nothing more real than water, and this special fluid not only holds the key to our existence and that of our environment, but can also unlock and store tremendous quantities of cheap and efficient energy. So how do we capture some of that energy without destroying the marine environment? The answer is to create lagoons. A tidal lagoon is a man-made structure that allows seawater to flow in and out according to the tides, and in doing so operates a water turbine which in turn generates electricity both on the incoming and outgoing tides and occurs 4 times a day. Because tidal lagoon technology is in its infancy, the current proposed construction techniques are very conservative. Aggregate material is poured to create the main impoundment wall structure and is protected around the inner and outer edges by the piling up of large rocks called rock armor. This system requires a wide sea base footprint, which not only utilizes vast amounts of material but also reduces the lagoon capacity. The stability of rock armor during storms is questionable, especially due to aggressive increased turbulence caused by the non-streamlined profile and rough surfaces. Jetstream Tidal Lagoon's smooth, aerofoil-shaped wall profile creates minimal turbulence and wear. It also provides an important additional effect similar to an aeroplane wing, whereby the water flowing close to the wall is speeded up relative to the main tidal velocity by up to 25%. We will now explain how this effect can be utilized in the Jetstream Tidal Lagoon system. Jetstream lagoons propose the utilization of a modular impoundment system which could be considered similar to a hypersize Lego block construction, although without using plastic, whereby the block provides the functions of a permanent smooth profile, together with equipment attachment facilities. These hollow sections are filled in situ with reclaimed seabed material which will cementify under pressure to provide the main structural integrity of the wall system. The turbine housing contains bidirectional power-generating turbines, allowing them to operate on both the inflow and outflow cycles. There are a series of WPT zero-energy Venturo pumps, which are attached to the outside of the lagoon wall. These pumps operate from the enhanced energy and flow that occurs around the lagoon wall to suck water out of the lagoon. This reduces the water level inside to below the natural low tide level. This means that at high tide there is an increased height between the water levels inside and outside the lagoon, so that when the turbine gates are opened, there is more power produced by the turbines and over a longer period. Here is an illustration of how the Venturo operates on the incoming tide. Due to the enhanced velocity of the tidal flow, water is transported through the pump around the central valve and exits the pump to re-enter the tidal flow. As the water flows around the central valve, it increases in velocity, thereby causing a low pressure to be induced on the exiting face. This in turn causes the valve to rapidly close. Upon closure, the momentum of water exiting the pump then draws water from the lagoon via the lower non-return valve. Pressures within the pump then mediate, causing the central valve to release to its original position to repeat the process. On the outgoing tide, the venturo operates in a reverse effect to pump water into the lagoon. This means that there is an increased height between the inside and outside of the lagoon at low tide. Again, when the turbine gates are opened, the turbines generate more power and over a longer period. Here is an illustration of how the venturo operates on the outgoing tide. With the flow now in the opposite direction, water flowing around the central valve causes it to rapidly close on the opposite face. The momentum of the following flow forces it past the upper non-return valve and into the lagoon. Pressures within the pump then mediate, and the central valve returns to its original position to repeat the process. You can see that the turbine gates are opened at around high and low tide and closed at times in between. This ensures that the turbines start generating power at the maximum height differential to maximize efficiency and power output. Remember, all the time the tide is flowing, the venturos are operating to enhance the power output of the system. The lagoon is split into two sections, thereby allowing servicing of the turbines without shutting down the complete lagoon. Thus, at any time, the lagoon can continue to operate at 50% capacity. The Jetstream lagoon system requires minimal maintenance, but as with all apparatus, there will be a service requirement. The venturos can be easily accessed by maintenance divers at low tide. Because of their simple operation and construction, they will only require occasional cleaning of large entangled debris or the easy replacement of rubber valve and seal parts. A tidal lagoon impoundment provides the perfect location for a solar power array, where it is sheltered from aggressive waves and wind effects. Jetstream lagoons have utilized this haven to include the significant advantage of additional electric power generation from the sun. This can be used in several ways: to feed directly into the national grid, to power additional water pumps to enhance the venturo's capabilities, or to convert the seawater into its component gases. The conversion is achieved through the process of electrolysis, where it can be stored on shore and either used as a direct fuel or recombined back into electricity via fuel cells for on-demand utilization. The Jetstream lagoon not only provides a modular and exportable system, but also the means of capturing 3 power sources in just one integrated structure. We may not be able to get something for nothing, but with an expected lifespan of over 100 years, Jetstream Tidal lagoons will provide the best something yet. They will provide long-term, sustainable and cost-effective power for generations to come.